Good morning, everybody. Welcome to this roundtable on the neurobiological basis of social behavior. I think it's fair to say that when you look at brain sciences as a whole, there are two ways of viewing them, the realistic way and the romantic way, sort of a strict constructionist point of view or a broader point of view.
And as a biologist and a geneticist, I'd like to understand what those basic building blocks are of behavior. And by studying simpler animals, we can see more clearly what the basic rules are. We can untangle nature from nurture much more easily. We can see what a particular gene is doing without trying to understand the whole complex environment in which it's operating. So, for example, Dominique Strauss-Kahn said yesterday in our introductory remarks that growth leads to peace. Well, what lobsters and flies and other animals are doing when they fight is they're allocating resources. If there are more resources, there are fewer fights. There's an underlying basic idea about the distribution of resources that's fundamental to aggression. And when they're short, there's always going to be more.
Most recently, I've been thinking about social interaction. But I've been thinking about it from a sort of odd perspective. Namely, I started thinking, if you were missing a limb, which I, of course, don't recommend, we would make up for that lack by putting a prosthetic device, the modern equivalent of a wooden leg, say. Okay? If you were given a complicated arithmetic problem, like, say, multiply two six-digit numbers together, you would probably want either a pad of paper and a pencil or a calculator, which would be like a cognitive prosthetic. So now we're not filling in a missing limb, we're extending your cognitive abilities so you can accomplish some task, filling in capacity you don't have. The main cognitive prosthetic we rely on is other people. So we use other people to extend our intelligence, to help us discover our emotions, to help us regulate our emotions. We're constantly embedded in these systems, which I call social prosthetic systems. The poet John Donne once put it, no man is an island. Well, our brains, exactly compatible with what Corey just said, our brains evolved in a social context, and we can understand how to play to our proclivities, that is what we're good at doing, and how to avoid falling prey to the things we're not so good at doing by looking at not just the brains of individuals, but how those individual brains interact when they're in groups.
But I think within 5 years we will know a great number of autism genetic risk factors, and then the hard work will really be before us. I think that's given the developmental disorders community a great deal of motivation and hope that you may have a developmental disorder fully manifest due to a genetic lesion, but if the action of that gene can be altered, that the nervous system is plastic enough, perhaps through the environmental interactions, to recover.
Social emotions such as embarrassment, compassion, guilt, the presentation of pride or submission, you can very easily find the forerunner of all those emotions in non-human primates. You don't even need to push very hard. It's not even metaphorical. It's right there, and it can be studied. In fact, the more I study social emotions, the more I think that one of the very few that may be exclusively human is the emotion of admiration and awe, which is one of the reasons why we're studying it very intensely in our institute right now using fMRI. Our feelings of joy or happiness or our feelings of anger or fear or sadness, all of these have correlates in activations of the insular cortex on both sides.
Biologists are sort of delusionally optimistic, and we're in this phase now in terms of neuroscience. But I think if you asked the 5 people around this table how far we are from the ultimate goal of understanding the human mind, we'd think we're at the very beginning. I mean, we have a solid foundation now, but we've got a very long way to go. These are the most difficult problems in all of science, and it's going to take more than a century to get a really good perspective on what needs to be done.